Hey guys, by the end of this video, we will have our delays working. So we'll hit something and it'll say hit something deadly, but it'll wait before reloading the level. You see that? It wasn't an immediate reload. It'll also do the same when we hit the goal. There's a delay. Awesome. See you in there. So first, a couple of quick fixes. I've noticed that my platform over here has been moved to a silly position where the player wouldn't actually be able to land on it because it's too far back in Z. So I'll reset that to 0 in Z if I can just do that. There you go. So now we can actually land on it. The other thing is that when a level loads, of course the pain here is that it loads instantly, but another pain is that it goes dark. And the reason it goes dark is there is a bug with the lighting, and I think it's just a bug in this version of Unity. Let me show you regardless how to solve it. You go to a window, lighting and settings. You'll get a lighting tab. Now this tab may not be docked, so it may be out, it could be anywhere, but it could be out in free space like this. What you can do is grab the lighting tab, drop it down somewhere if you want to, but the important thing is really that you select a level, doesn't matter which one, we're going to need to do it the same for each level. Go to the lighting tab, the scene tab of that, and at the bottom of the scene tab, it's actually at the bottom all the time, regardless of how you're scrolled, you have auto generate. If you untick that and click generate lighting, what it's going to do is it's going to make a folder, in this case for level 2, full of lighting information, so it doesn't have to recalculate it and get it wrong, okay? And then we can go to level 1, saving our changes, turn off auto generate, click generate lighting, and off we go. We're almost at the point where we need to start organizing our assets, but not quite. We've not quite got a screen full yet, so we're okay. So that'll solve the problem. Now, if you play the game, boing, hit the roof, and the lighting problem is solved. So now we're just left with this issue that it loads the level so quickly that there's no time for any fanfare or sparks or sounds or fireworks or anything, and that's what we're going to solve. So what we want is to be able to go from an alive state as a player to some sort of dying or transcending state. So I'm going to use dying when they hit the wall and they're dying, and I'm going to use transcending when they are waiting for the next level to load. So they're kind of transcending to the next level, just for a bit of fun. And then what we need is some sort of continuous question that says, has the timer expired? If it hasn't, then we stay in the dying or transcending state. But if it has, we carry on with our lives and we load the next level or we finish the game or whatever. But remember that if we're going to use a timer in here, then other messages are still going to arrive while we're waiting for the timer. This is a bit like addressing a letter to yourself. In fact, quick bit of self-development. If you really want to get something done, write yourself a letter. Say, Dear Ben, I hope you're reading this. When you're reading this, you've managed to achieve the goal you set yourself, blah-de-blah-de-blah. And you can stick it in the post and it'll come back to you and you're writing a letter to your future self. But in the meanwhile, your life goes on, right? And other things happen. But the purpose of doing an exercise like that is to change your behavior in the interim. And what's going to happen in our code is that while our timer is running, the code is going to keep going because we can't stop execution. If we stopped execution, everything would freeze. The movement of the ship, any sounds, any fireworks. So we need execution to carry on. And this is actually something called a coroutine, like a co-pilot. And it means that something else can be going on alongside what we're doing. This timer can be going round and waiting, but we can also be doing other stuff. And the way that we're going to introduce this is using a method called Invoke. Now, I've put a link in the resources for you, but you can read all about that. It's a gentle introduction to something called coroutines, all right? It's not my favorite, but it's a good place to start. So what we want to do is, rather than just immediately loading scene 1, what I actually want to do is encapsulate this behavior into something else. So I'm going to start with an enum for these 3 states. So enum, state. Now, if you want a micro challenge, finish this off. Create the states alive, dying, and transcending, and make a member variable for them. See if you can do that as a micro challenge, just so you remember the format. All right, so the 3 states we're going to give are alive, dying, and transcending, like so. And then I'm going to go state with a capital S because it's the type now. Then I'm going to make a variable called state with a small s without apology. And I'm going to make it default to alive. Now I can just type alive and it should find it. Awesome. So we have this state thing that we can use. Now what we want to do is go ahead and use it. What I want to do is introduce a new method. Instead of just loading the scene, let's put that into a function called, what is it? What are we doing on finish? We are load. We're going to load the next scene. Yeah, that's what we're going to do. We're going to load the next scene. And in the future, so to do, allow for more than 2 levels. All right. But at the moment, we're just going to load the next scene and keep it really simple. Now, we can't just load the next scene, can we? Because it's going to load the next scene, and it's going to load immediately. We've done nothing at this stage. All right, we can probably get rid of this finish comment. What we want to do is delay the call to this load next scene. Now, the way we can do that, excuse me, clicking in the thing there, is we can use Invoke. And unfortunately, you when Invoke works, you cannot provide, you have to use a string is what I'm saying. It's going to want the method name as a string. Now that sucks a little bit, but you can always wrap it around like this and, you know, use a bit of common sense to turn it into a string or copy and paste, but just get the string name right, i.e. get the method name right. That's kind of super critical. So you invoke load next scene, and you do load next scene after, I don't know, let's just say 1 second for the moment. 1f. Remember, floats, you have to specify that they are 1 second. So it's load, there's two parameters here. Load the next scene, which points down to the load next scene method. So this guy here is looking for a string here. And after how long? After 1 second. All right. And there's a couple of things we ought to be doing here. One is we ought to be saying, okay, let's parameterize this time. So let's not do it now, but this 1 second is a design parameter. The other thing is that the order in which I created load next scene, I used the refactoring tool and it made my method static. We don't want that. We don't need to know what static is right now, but we just don't want it. So if your refactor tool makes a method static, get rid of it. You can leave private, but get rid of statics until we understand what static is. We won't use static much anyway. So this says, call this method by name. Unfortunately, if I rename this method now, this will break. And that's the problem with this, but otherwise it's nice and simple. Load the scene after 1 second. All right, let's see what happens. Oh, also, we ought to set this enum, shouldn't we? So we come in here so that we can keep an eye on the state the machine is in, or the rocket is in. So we can say state equals, what happens if we finish? We're transcending, aren't we? And a semicolon. Oops, in the right place. Try and get it in the right place. We got it in the right place. Okay, so when you finish, you set the state to transcending and load the next scene in a second. Let's just look at it and see what happens. So let's try getting to the finish. I'm going to inspect the rocket ship in debug mode. Oh, see if I can actually get there. By the way, the reason it collapses down when you die is because that's not the same rocket ship anymore. So if we die accidentally when trying to get to the level end, then the reason the hierarchy goes away is because the rocket ship is a whole new set of everything. All of the game objects in the scene are new. Boom, and it goes to transcending, and then there's a little delay and it reloads. So that system seems to be working, which is great news. All right, fantastic. So what I want you to do then is I want you to delay the level load on death. We've just delayed it on success, but let's delay it on death. The first level should still load when you die, the same flow. There should be a delay before it does so. And the player control should be disabled while you're dying. It's a little extra challenge using that enum. And we suggest you create a new method for this. A new method, something like load first level. Okay, go ahead, pause the video, and I'll see you when you've got that challenge done. All right, let's deal with the first bit of it then. Welcome back, by the way. What we want to do is we're dead, so we want to immediately set the state. We want to say state is state.dead, or dying, rather. We are dying, we're not dead, we're dying. Okay, so we're in state dying. Now, we're going to make a new method. It's going to be very similar to load next scene, but it's going to be called load first level. And first level has index 0. And it will always have index 0, so there's no funny to-dos. Now, I don't like the inconsistency between the use of the word scene and level. Strictly here, we're asking to reload the next level, so load next level. But the refactor tool hasn't helped us, okay? That's the problem with Invoke, so we need to paste it in there. You didn't need to do that in your challenge. I'm just making these guys consistent. So, if we hit the finish, we transcend and load the next level after a second. And if we die, then we're going to do a very similar thing. We're going to load first level after a second. And again, we should parameterize this time. Either as 2 parameters or 1, doesn't matter for now. All right, so we're nearly there. Let's try this, see how we get on. I'm not sure we've completely completed the challenge, but let's see what happens. If I go hit the wall and watch the rocket ship's parameters or state, boom, goes to dying. Okay, now can I control the ship when it hits the wall? Yes, I can still control it. So the final bit was, and this is the benefit, of course, of having this enum, is to come up here. Now, before I do it, let me just explain what's going on. I'm going to zoom out from the code a little bit so that you can see in a little bit more detail what's going on here. We have in here called an invoke for the first time. All right, now what happens is this means that sometime later, or specifically after 1 second, that this function down here, the load next level, will get called. But in the meanwhile, in that intervening second, the other messages like update and on collision enter can both be called. All right, so life carries on between the time you sent the letter to yourself and when you actually receive it. So Of course, we can keep controlling because update's still being called every second. The game is still running while we wait for load next level to be called. Now, you may wonder, how's that working? You can kind of think of it like when we do the invoke, there's a separate kind of time-based queue over here, and it just sticks our invoke on the queue and says, okay, I want you to load next level in 1 second's time. So this is like, this bit of the queue here is like t+1, and this is time equals 0, t equals 0. It's like a rocket countdown. So in a second from now, whatever else you've got to do on your plate, Mr. Unity Engine, please remember to load the next level, and then it does so. But meanwhile, these guys keep getting called. All right, not start, but update and on collision enter. All right, hopefully that's clear. So what we want to say on update is quite simply if our state is equals, remember, alive, if we're alive, then process the input, both rotation and thrust. You could leave one out. You could say that you're allowed to thrust but not rotate when you're dead, but I'm going to say no. If you're alive, do that, otherwise do nothing. So let's see what happens there. Should be roughly the same, but if I hit the wall, I suddenly can't control and it's free-forming. Now, I heard that the sound carried on there. So somewhere in this scheme, we'd better be stopping the sound. I don't know where. I don't want to think about it at the moment. So because I'm here, I'm just going to go to do somewhere stop sound on death. Okay, and I'm just going to leave that as a to-do for the moment. Awesome. There's just one more little trick up my sleeve. If we were to put a print statement back in here, hit something deadly, okay, in the collision enter. Remember I said that this could be called as well in the intervening time while we're waiting for the level to load. Well, let's see what happens to that print statement. If I just boost, boom, look, hit something deadly has been called 4 times before the level got a chance to reload. So what we need to do is we need to say to on collision enter something very similar to this, but kind of the opposite. And this is how I like to do it. I would like to say that if state not equals to alive, I don't want to go through all the other possible states, but if we're dead, then return. We could lay it out like this, right? And now let me explain what this does. This says that if we're not alive, return. It means leave the method, stop execution at this point. It will not get any further than this. This stuff will not get executed. So every time the on collision enter message gets called, it will just leave, okay? It's like a guard condition at the top of on collision enter. Let's see it in operation quickly. It should mean that we only get one hit something deadly. Why do we care? Because we only want one. Boom, hit something deadly just once, all right? That's good. That's much tidier. Now, I am tempted with this to lay it out differently. I'm tempted to break my rules about my formatting. There's 2 things I could say here. Firstly, you could say else and then put all of this stuff in an else block, but that's horrible, right? Because if you put all of this in an else block, then look how indented we are. We are too indented, too far in. Yuck, yuck, yuck. Don't like it. Not easy to follow. You also don't need an else because return leaves the function. Just quits it straight away. So it's the same thing saying else as not saying else. And this thing is a very self-contained thing. So what I want to do is just put it all on one line. I just like that for just a guard condition that says, hey, if we're not alive, return. Just ignore collisions. And if you want to put that in, if you like, when dead. Simple. All right, so there's a little idea for you. And now I will see you in the next video.